Okay, this week's tutorial, week 9 tutorial, is on the quadratic formula. And we use the quadratic formula in order to find the solutions of equations that are perhaps not easy to factor. And if you look at 6q squared minus q minus 15 is equal to 0, you might notice fairly quickly that we are not going to be able to factor this thing in such a way that we have integer solutions. In other words, if I were to try, say, 6q here and q here, and I know that my signs are going to be different because of this negative symbol here, I might try a plus here and a minus here, and then I have to toy around with, what numbers multiply together to give me 15, but would have a difference of 1. And so I may use trial and error and try, let's say, a -3 there and a +5 here. And I can look at all different combinations, of 6q and q and 5 and 3 or 3 and 5. And then once I realize that's not going to work, I can switch to 3q times 2q. And after doing trial and error, I come to the conclusion that this thing is simply not factorable in the sense that I have integer solutions. Some people bypass factoring altogether, and they look for the solution using what is known as, again, the quadratic formula. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is going to be the coefficient on the quadratic term. And the quadratic term is the term that has the 2 for the exponent. And that means that a is +6. And b is going to be the coefficient of the linear term. And the linear term is going to be the exponent of 1. And notice that the coefficient there for the linear term is an understood -1. That's going to be the b value. And lastly, c is going to be the constant term. That's going to be the term that doesn't have a variable associated with it. So c in this case is -15. So at this point, the rest of it is just plug and play. If a is equal to 6 and b is equal to -1 and c is equal to -15, using the quadratic formula, all you really have to do is make the substitution and pay very close attention to your arithmetic. If b is equal to -1, then I have negative b here, right? Because we know that it's negative b. We have our plus or minus here. The square root of, again, since b is -1, we substitute that in place of the b here. That's going to be -1 squared. And I would go ahead and advise you to make sure that you always put your a, b, and c values inside parentheses. That just makes life a lot easier. And that's what they did here in this example. So I have b squared minus 4 times a, which is 6. And again, this comes straight from the quadratic formula, times -15, which is going to be the c value, all over 2 times a. And again, since a is 6, I have 2 times 6. And from here, we just continue to simplify until we can't simplify any further. And if they take, obviously, minus a -1 is a +1. That's how they get +1 here. They carry down the plus or minus. We know that -1 squared is 1. And we know that we have 6 times 4, which is 24. Multiply 24 times 15. That's going to give you -360, but you have this minus in the front here. So 1 minus a -360 is 1 plus 360. That gives us the square root of 361. And then, of course, in the denominator, we still have 2 times 6, which is 12. At this point, I would recommend just taking a calculator, and hopefully the square root of 361 is a perfect square. It turns out to be 19. So the square root of 361 is 19. And what does the plus or minus mean? Well, from the very beginning, plus or minus means that you probably, although not always, you probably have 2 solutions. The two solutions being negative b plus all of this divided by 2a. And then you have to consider the fact that another solution could be negative b minus all of this divided by 2a. So normally, again, not always, you will get two solutions. And they considered both possible solutions. They looked at 1 plus 19 divided by 12. Then they looked at 1 minus 19 divided by 12. And the rest of it is just simplifying. On the left side, I know that 1 plus 19 is 20 over 12. And then I have 1 minus 19, which is negative 18 over 12. And then if you reduce the fractions, 20 over 12 gives you 5/3, and negative 18 over 12 gives you negative 3/2. So we have two solutions here for Q. One solution is 5/3, the other solution is negative 3/2. And if you were to take 5/3 or negative 3/2 and plug one of those into this equation for Q, you would get 0.